Draper. Draper. Come on. Come on. Up here. Come on, up here. I'll give you a helping hand. Help me with this radio, mister. Oh, hello, everybody. Welcome to my shop and my cat. And the noisy radio, which we're going to try and take care of here. Yeah, there's the cat. Draper has decided to come and help this morning. As we get this radio ready. Now, let's recap. Done a lot of work on this radio. And the last test ended with some pretty... What are you eating? What's going on here? What do you got? Uh-huh. One of the cat's favorite toys. The rubber band. We have to keep these scarce in our house. So, last time I operated the radio, it ended with some pretty loud puffing and crackling. And since then, I've gotten a number of suggestions here on how to approach the next steps with it. They're all good ideas. And a good number of you are guessing that the tube pins need attention. That's a really good guess, no doubt about it. And I've got a few comments around capacitors, really mica capacitors, and this thing called silver disease, which I'm not so sure silver disease would occur in this radio, but similar sorts of capacitor failures can happen. So my question is, should we set this thing up and have it operating while I start wiggling tubes and stuff like that to try to come to grips with where the problem is, or should I just pull the tubes out, clean all the pins, clean them up, stick it all back together, and then try it? I think if I were to do that, if I were to pull the tubes out, clean them up, stick them back in, and then we find the radio's quiet, then that would be quite a satisfactory result. I really don't care which tube was making the noise. So I don't think there's any loss of opportunity in learning or investigation in doing that. So I'm going to stop talking. That Draper's causing trouble in the other part of my shop. Look, man. Oh my God. Look, cat. If you're going to be in here, you got to be helpful. Okay, that's the deal. So come over here. Give me a hand. Give me a paw. You can't give me a hand, can you? Give me a paw. Okay, so let's take a fairly close look at these. We'll see what we can see from them. Now, I've got my camera focus set to manual here, which I learned to do yesterday. How to manually control the focus on this camera. And let's just see. See what we can see. Well, you know, 95% of tubes that I look at like this, the pins are really quite shiny and clean. And this one's in that category too. I've really only had one tube ever that I pulled out and found the tubes pins to be heavily corroded. And believe it or not, it was one of these gigantic Russian tubes, a 6C33, which is a modern tube with gigantic pins on it too. Those tubes run really, really hot, and the high temperature encourages corrosion too. And you know, where that occurred, there were a total of 8 of those tubes. 8. Boy, you better look this up on the internet. 6C33. Can you picture 8 of them? If you hunt through my videos, you'll find videos on an OTL amplifier. And in there is a video on the tube pins. So I'm not seeing much there to clean, really. My usual practice is just to go around like this. Oh, right, you can't see that, can you? Oh. There, that's better. Now you can see, and so can I. I can see what you can see now. So that's my usual technique right there. I figure that scrapes the pins where they need to be scraped. I'll tell you one thing I don't like doing is wiggling the glass tubes. The glass tube is just glued into the base, and over the years the glue can fracture and break away. And next thing you got is a loose glass bulb, and you're not long from having the whole tube fail. So I'm really not so happy. So we'll take a look at the pins on this one. We'll take a look at the pins on this one. What do I see? I see something interesting there. That's for sure. Let me steady my hand here a little bit. The pins are clean. The bottom half, the upper half, not so clean. Like they're very bright on the lower half, but not on the upper half. And what is this tube that we're handling here? This tube is, I have no name on it. Where's my info? Looks like a rectifier tube. This one looks like an output tube. This one looks like a rectifier tube. Maybe it's down here on the base. 1931 to 48, so this tube's from 48 or later. Huh, no sign of the number on it. Now, perhaps somebody in the past polished up these tubes and wiped all that off. Well, I bet you the clean part is the part that's doing the connection, but a little bit of cleaning on these wouldn't hurt. I wonderfully reorganized shop here, my forever reorganized shop. I have to think hard about where. When I'm done with everything. Oh, I'm sorry, left you on that out of focus camera, so. So just a little bit of light sanding here. I'm not doing anything serious to it. Because I really believe these things are coated with or a type of metal that tends to not corrode. And like I say, I usually find them quite shiny when I pull them out. And this can put grit into here. And the grit, if you get too much, especially if you use sandpaper, you get too much grit in here, and the grit can get between the pins and the contacts. I'm sure you're not terribly impressed with that cleaning job, but frankly, I really think it's enough. I think the deal is to wiggle the tube here. Wiggle the tube as we go down into place. Let's see, there's a number on this one. Yeah, 6F6. Yeah, so this is the output tube. I think this is it. Oh, I can read it on the top. I didn't see it before. I can see it now. 5Y4. Rectifier tube. Let's just let's pull these other tubes out here. We'll start with this one. Now, just the act of pulling them out is already starting to clean them up. And again, they don't look heavily corroded at all. Fairly shiny guys. Hey, ever wonder where your odd socks go? All your odd socks that you lose? They all end up in my shop. This is one of your odd socks. I got them. what if we do this and the radio still makes pops? Can we be sure it's not the tube pins? Well, we can't be sure of anything, can we? But I think after doing this, the odds that the tube pins are responsible is very low. You see, I hadn't even taken the tubes out of this radio. I hadn't even, the wiggling thing, I hadn't done that at all. So these things were exactly as they were. So I think a little bit of mechanical manipulation here is all it's really going to take to overcome any problem here. So if the radio is still making noise after this, you can be pretty sure it's something else doing it. This one's not quite as bright and shiny. There we go. Yeah. There's a lot more dirt up in here. Oh, you know why? Maybe it's on the back of the radio. So stuff that's located close to the back of the radio is literally more outdoors than the stuff at the front, and it just tends to collect more junk and dirt and stuff. So we'll give this guy a little bit of a sanding here. I'm not using sandpaper, by the way. It's not really a sanding. Again, I'm a little bit worried about just ruining the coating on the pins, if there is such a thing. I mean, obviously the manufacturers were picking materials that they were pretty sure wouldn't cause problems. You know, in the 10-year time frame, they were probably figuring this radio would be in service before the consumer would want to buy a more up-to-date radio. I'm sure they didn't figure on these things lasting this long. I mean, who does? I mean, look at the laptop right in front of you right now. How long do you think that's going to be around? I bet you think it's going to be around another year or two. Sit around in a box for 2 or 3 years and then finally off to recycling or wherever they go. Got no intentions. Nobody's thinking, let's make this laptop run 40 years from now. No one's even got that in the back of their mind. Oh, you know what? There probably are people. Probably are people putting away laptops and all kinds of stuff. It's kind of a crazy kook would think something like that might be of value in 30, 40 years. Now I have a collection of about 5 Commodore computers. I'm guilty. 4 or 5 Commodore computers and all kinds of Commodore stuff from years ago, just sitting in storage here in my house, and I'm thinking someday that computer will be worth something, but the fact is there are so many of those Commodore 64 computers around in the world, mine will never be scarce. Somehow I just can't bring myself to throw them all out. I do have an interesting computer in the house, a vintage computer, and I'll have to bring it in here someday. I haven't turned it on in years now, and it's a very special computer. It's also a Commodore, but it's more like a professional Commodore computer, not a around-the-house computer. Came from the University of Waterloo. It's called a SP9000, I think. Someday I'll have to bring it in here. Well, okay, I've monkeyed about with every tube. So I think we should give this guy a shot. And I think I'll hook him up off camera, and we'll turn the camera back on when I got it ready to go. Okay, so that just took a minute here to plug in the speaker, connect up an antenna. So here's the antenna wire here. And switch is off, switch is on, but the volume is down. And we should be safe to go. I'll hook up my hot chassis light here just in case, but it really should never occur with this radio. But why not be just a little more careful? So I think we're all set here. You can see my signal generator is already running. I'm letting it warm up a bit in anticipation of maybe even doing an alignment on this radio, which is really what I'm trying to get to at this point. Everything looks okay, so let's give it a go here. Okay, so I'm going to put it on restricted power. Did I turn it on? Yes, it's on. Volume down. Here we go. You watch this meter. Whoa! It came up and went down really fast. That's how long it took the heater on the rectifier to warm up. Since there's no cathode around the heater, the electrons are emitted right from the heater itself. It's just a fraction of a second for this to be hot enough. It doesn't have to in turn heat the sleeve, the cathode sleeve, which would take more time. Okay, so I can see my current restriction bulbs are lit up a little bit. Voltage running around 85% of line voltage. The light is on, the front. Let's turn up the volume here. And it sounds just fine. Now, we got a resistor here that was getting crazy hot, which I'm still a little concerned about. Even if it's not bad for the, it's 39, it's 56. I'm getting 56 in there already. So even if the resistor is designed to run at those kinds of temperatures, and I think it is, I think that's why it's capable of dissipating this very large wattage. It can just take the heat. At a very high temperature, it throws heat off much, much faster. So, so we can dissipate the energy, the heat energy, even though it's a little tiny resistor compared to that old one. Well, until it shows some real signs of difficulties, I'm going to just ignore it for now. And listen, I don't hear any crackling. No crackling. Of course, I'm on restricted voltage here. It seemed to me the crackling came just after I elevated the power line voltage to full. And we're still running with the original filter capacitor, which is a scary thought. And I did not hook up our B plus meter. Why don't I do that while we let it run here for a bit? And we'll see where we are on B plus. I would like to see the change when we hit the switch too and put full power on the radio. I think that might be a little more interesting. And now, pick off the, I'm going to take the high voltage that's right on the old capacitor here. And you can see the meter jump up. I'm on the 500 volt scale, so that's running around 325 on that meter. And as I say, there's no crackling at all. We can hear the, I didn't mention it before, but some of you noticed the microphonic tube in there. Let's see if we can figure out which one it is. It's not the output tube. Oh. Yeah, I think it's the 6Q7 tube. What is that tube doing? Don't know offhand, but it could be the preamp. I don't have the schematic right in front of me here. Of course, if I just pick it up from here, I do have it in front of me now. Is this the right one? Sparton. Yes, absolutely. And I was curious about the tube there. The ringing tube 6Q7. Yeah, second detector AVC and producer of the audio. 6Q7 is a little microphonic. You kind of expect that in the audio circuits, not in the RF circuits too, but I guess it could occur anywhere. Well, let's give it full power here. And we'll see what transpires next. Watch this. Keep your eye on this voltmeter. Well, that took it up to 400 volts. Wow. On that old capacitor, it makes me want to put on my goggles here. No crackling. Let's see where that temperature that resistor's gotten to now. Highest reading I got is 85. That's pretty hot. You wouldn't want to touch that with your finger. '85. Usually up around 110 degrees C. In that range, you start degrading organic materials like paper, oil, organics. Not too good at that temperature. Most organic materials pretty good at 90 degrees C, believe it or not, such as paper and oil. So you don't want to go much over 90. Now we're pretty close to it. Of course, there's no paper and oil in the resistor I'm talking about, so the hot resistor, so it's really not an issue from that point of view. Well, I don't hear any clicking and popping. So at this point, I'm willing to concede 2 pins was the source of the very loud popping. That's easy to see. Could have been in the audio output tube. Could have even been the rectifier tube. And maybe even any one of the other ones, for all I really know. So I think it's good for a bit of an alignment here. Yeah. So why don't we attend to that? We're going to align. I'll turn them down here. And the interesting thing is I've switched microphones again. I've switched finally back to the microphone I was trying to get away from. That's the microphone that's built into this camera right here. And the thing I don't like about the microphone is it has noise reduction processing in it, and I can kind of hear the computery sort of, I don't know, manipulated sound from it. It's just not as clear and natural as ordinary sound. But one of the benefits is you'd think my shop is totally quiet. I got the furnace running behind me right now. I don't think you can even hear it running because of the noise suppression system in the microphone, or the software that runs with it, or however they do it. I'm not sure. One thing I think it does is it makes it hard to hear some of the noises that are coming out of the stuff I'm working on. So what's going in my ears could be quite different from what's going in your ears. And I cannot listen to the program material being picked up by the microphone because there is a slight delay in the audio. And I think, as I've said before, if I put my headphones on, I can't talk. If you've never experienced that, you gotta go find something with a slight delay in the audio and put on microphones or put on headphones. You can hear your own voice slightly delayed and see if you can talk. It's quite an effect. Okay, still no popping. I don't know why I'm hesitating. Let's see. I'm pretty sure that's the AM band. And the instructions say, set the oscillator to 345 kilocycles. Connect to the 1C6 grid cap. Adjust trimmer C33. Now this is what I was just about to do when the thing started popping last time, wasn't it? I think I was hunting for C33. 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 Yeah, I have a bit of an idea here I'm going to try. Let me just stop the video for a minute and start it up again after I get this idea. Okay, let's see if I did this right. Now this is a little tricky to do with a one-screen computer. What I'm trying to do is get the here we go. Okay. So C33, as it turns out, I remember this now. This is just before the popping started. C33 is on this IF coil here, accessible from the back. Great. Okay, now we're ready to go. Let's hook up the signal generator properly here. And it's supposed to go on the grid of the 1C6. And where is the 1C6? One C6 is the tube that's really hard to see the label 1C6 on it here. So that's the tube. 1C6 would be this guy here. Okay, so I'm gonna. This might be a little noisy when I do this. Big long lead, that's kind of bad. There we go. Okay, it was 345, right? 345. Oh, not a thing. What's up with that? Uh-oh, a little bit of clicking and popping. I think maybe my signal generator connection. Oh, I don't have the signal generator connected. Right, that's a good thing. That explains that. Okay, so let's. And the signal generator output is low. There. Now I get the signal generator connected. It's taking quite a signal. I don't have my signal generator grounded into the radio, so let's do that. This also might make a bit of noise. That's a lot better. Now, by my ear, it's maxing out right at 345. Of course, my signal frequency counter is a little off, by the way. So now we need to hook up a output meter. If we're going to do this accurately, you really do need a meter. Now, what's that? I'm wondering why it's suddenly so loud, like you can hear the momentary, really loud signals now. AVC effect? I don't know what it is. It was just the AVC, a momentary break in the signal. AVC brings the radio up. Moments later, signal fed back in. Now the AVC has the radio turned up, so you hear that. I don't know. I don't know. Okay. Lots of stuff to sidetrack you when you do this. Hey, what is that? I got a bad clip lead, maybe. Okay, check it in a moment here. Can't make a clip onto this. I'm using these terrible clip leads again. Huh. Holy shit. Come on. Oh, I got it. Now, I got that on screen? No. Let's see if I can get my signal meter into the picture here. There it is. Okay, so that's the signal strength meter. All it's hearing pretty much a buzz right now. Let's turn the volume down. Watch the meter. Didn't go much of anywhere, did it? Why is it doing that? Now let's give it a better signal here. Okay, now we're going to prove that the meter is reacting to the tone. That was my furnace shutting off. Okay, so let's, I'll decrease the signal level, the audio signal level being fed to the radio. And there it goes down. Can you see that? You can't see that. It's going up and down. Okay, so we're about 30% modulation. Okay, we're ready. We're all set now. So adjust something. What are we adjusting? C33. Notice it says adjust trimmers. C33. So the C33 refers to both of these trimmers. Here we go. Let's see what happens. I want to get in front of the meter here. It's a little sticky there. Looks like it was right on the peak, doesn't it? We'll do the other one. What's happening there? It's moving around. I'm not doing anything. Oh, 1 second. Phone's ringing. Gotta